Today I thought we'd go over some of the midterm, anything that was generally unclear, and maybe some topics that you want to review. We can review together, or you want to review, pay more attention to in your own study. The remainder of the semester, this is week 9, so we have, including this week, 7 more weeks. And we have differentiation to complete. So differentiating more complex functions, so exponential and logarithmic functions, trigonometric functions, and L'Hopital's rule, you might touch on. It's a simple rule, really. And then, is there anything else in differentiation? That's most of it. We might revisit the chain rule if we need to, or not. And then we'll go into integration, which is the kind of opposite process from differentiation. Hopefully we should have time to also look a bit at sequences and series for the end of the semester. So we have a number of topics to cover, and I think that in order for us to get through it, it will require, which I'm sure you're already doing, but to continue doing, is to be reading along in the text, and that's how most every math course I've ever taken in university is. You're really learning through your own study. And the classes are for clarifying things that you're not sure about, didn't quite make sense, but you never just rely on lectures to teach you. Any questions or suggestions or comments? You know, you can always, at any point, this is an interactive class, you should know that by now. Yeah. Alright, so you all got your midterms back. I know we spent some time on it. It's now 8:30, so I guess you have an hour and a half, not quite a full lecture. First, I apologize that I was late this morning. I had an unexpected thing that took about 15 minutes before I left the house. So, shouldn't happen again. So I sent you all your midterms. Because I was traveling after you'd done your midterms, I asked that they send it to me, they scan it and send it to me, and so I marked it electronically. So I haven't yet put them on the paper. So I have the papers and you can come get them later, but I won't redo the marking on the paper, I'll just write the score. But the marking and comments are on the digital version that you each receive. Did you look at yours? I know you looked at yours because you looked at it last week.
Yeah, okay.
You have it there, okay. So do you want to go through every question and just say, hey, pause here, or do you want to just say, can we look at this question? Did you have questions about any parts of it? Or
Question
number 2?
Yeah.
Mona, do you have parts you want to look at more?
Mm-hmm.
All of them?
Yeah.
Okay. This one, I think most people did well, unless the only issue that happened in this one was getting the signs wrong. So when you square a negative number, what you get is a positive number. And I think you all know that, but when you're doing the algebra, sometimes you forget. And I think almost everyone, or not everyone, somewhere in your exam, you got a minus sign wrong, which is probably the most common mistake that even I have made. Everybody makes it at some point, but you have to then be careful and really look at what am I doing. the other kind of mistake that happens is when you have this kind of minus 7 over x minus 1, right? And you have like minus the whole expression, 7 over x minus 1. And in other parts of the exam where there's, let's say, minus 3x times something in bracket that has several terms, something plus something minus something, you have to multiply through each of the terms inside, again keeping track of the sign. So maybe we should do an example like that. I'd have to connect this guy, which I can do. Yeah. Can I do it? Yeah, I think I do it like this. So. Oh, this is the. Let's just make a new note for today. Okay. Let's see. Can I do this and then? Oh, is it gonna recognize me? Yes, it will. Excellent. I'll have to plug in the battery soon. So what I'm saying is something like this. How would we approach this? So there's an expression here. There's two ways of thinking about it. Actually, I have an idea. Hold on. I'm gonna add 2 minus this. Okay. So let me undo. Is that this one? Yeah. Let me undo that. What in this expression? What is multiplying the parenthesis?
So,
what is multiplying the parenthesis?
negative 3x.
Negative 3x?
Yep.
So, what would be the full answer?
4.
If you multiply out all the terms, what do you get?
Is this co-encoded?
It's part of the expression, yes. Can you do it out loud with us?
I think we'll do negative 3x multiplied by 5x, which is going to give us negative 15.
Negative
And
15.
then negative 3x multiplied by 3x squared, which is going to give us. No, that's supposed to be negative 15x squared.
Okay.
And then we'll have negative 9x cubed. And then negative positive 18. Positive 18x to the power 4.
Is that all?
Yeah.
We're missing
So I
something.
was asking, is this 2 part of it or is this?
If it's there, then it's part of it, yeah. So where does 2 go? What happens with that 2? You mean start with the 2? 2 multiplied by 5x? Mm. Then minus this. So let me put in a different color. So 2 times 5x would be 10x, right? And then what? Here. Plus 6 what?
X squared
And then?
minus 12x cubed.
And then minus this whole thing?
Yeah.
Are we agreed?
I don't know, I think I'm confused.
Why are you confused? There is an issue with this. This is not the correct answer. So if you're confused, that's good. You should be confused because this is not exactly right. So there's two things here. One is, let me see if you can spot it. Suppose I write this. Would this make a difference? Let me do it in a different color. If I put 2 minus 3x in brackets, so sometimes I'll say brackets, parenthesis, same thing, just brackets is easier to say. Is 2 minus 3x in parenthesis the same multiplied by the other thing? Is that the same as without the brackets? Are those two
I think
things?
it's not, because if it's in the bracket, that means that's one thing. If it's not, then yes, those are two different things.
Mhm. And if they're two different things, then
If it's like that, then the 2 minus 3x is 1.
the 2 minus 3x is 1 what? You're saying with the brackets it's 1 or without? Yeah.
If it's with the bracket, then it's 1.
So these are the rules of, what do you call it? Operator precedence? Or is that what we call it? So when you have, right, 2 minus 3x times something, right? Imagine I now write plus 4x squared times something. Now do you still think the 2 multiplies the bracket? Do you still get the 3? So let me go back to the original one where we don't have this. This was the original thing, right?
Yeah. That's the me. I'm still standing on my answer.
You're still what?
Standing on my answer.
Uh-huh. If I write like this,
Yeah.
and then I ask what is this equal, are you going to start with this and then add that?
Yeah.
Yeah.
Mhm.
Can you, does this 2 multiply this bracket?
Yeah.
Really?
Mhm.
No.
Why?
Because there's a minus in between.
So.
Hmm?
So.
So when terms are things that are separated by a plus or minus sign. So this is one thing, and then I add another thing, and here there's another thing. They don't multiply each other. You're adding them together. So actually, in this case above, all we need is, and we don't get that, we just get 2 minus the whole thing. So this is something you need to review more of. I think there's some sections in the textbook where if you need more examples of exercises, you can look some up. Because if this is not clear, then you're always going to have a hard time arriving at the correct answers. Trying to think of an example that would.
So it's 2 minus 8, but when we are multiplying,
This is one thing,
that
this is one thing, this is one thing. And now, if I write, if I take this and I write 2 minus 3x like this, and then there's another bracket with something inside, now this will plus 4x squared times whatever. Now I only have 2 terms. Right? These are 2 separate terms because of the minus sign. This is now a single term because a bracket is one thing. There are 2 terms inside the bracket, but the whole bracket then is one object multiplying another object. So the whole expression has 1 term plus a second term. So knowing how many terms are in an expression is important, right? And they are multiplied once you take all the things that get multiplied together, those are 1 term. It could be just 3x times 6, right? Or 3 times x even, if there was no bracket. So 3 times x, that's 1 term. 4 times x squared, that's 1 term. Multiplied by something else. So you can multiply or divide many things together, as long as they're all a product or a quotient. That is 1 term. As soon as that thing we say now plus or minus another thing, that's now a new term. So this idea of terms is fundamental to algebra. And if there's confusion about, you think 2 multiplies this, you're always going to get the wrong answer. Right? So understanding terms is critical. Okay, so that's not this one. It's in here somewhere, I think. Okay. So that was the main issue here. Otherwise, the concepts, how you substitute in these expressions as x approaches the limit, to find the value of that limit. You all understood how to do it, but you maybe made mistakes in the algebra, as we just saw. And I think you all also recognize that down here, that here, this is equal to the limit of f of x minus the limit of g of x. And here, it's the limit of f times the limit of g. This is the limit of f over the limit of g. Some of you wrote out the expressions and tried to simplify it to find. The idea was to see that if you got the right answer, you got the right answer. But the rules of limits, the laws of limits, is that the limit of a sum is the sum of the limits. The limit of the difference is the difference of the limits. The limit of the product is the product of the limits. And the limit of the quotient is the quotient of the limits. So if you know if you know the limit of f of x and the limit of g of x, then you can just go, well, the limit of f as it approaches 2, I found it further up there somewhere, it was 7. And the limit as g approaches 2 is minus 11 from b. So I just put 7 over minus 11, which is minus 7 over 11. Same thing. Does that make sense?
Yeah.
Then this one. So one is, I think the phrasing of the question was not clear because most people did not fully fill out this table. So the idea was, and maybe you can suggest to me, how would you write the question so that you would understand what is asked? Would you read it for us, Augustus? Is it Augustus or Augustus?
Augustus.
Augustus.
Yeah, some people don't actually finish the Augustus.
And they just write
August.
August.
Like August. Yeah.
Okay, but your name is Augustus.
Yeah. So below is the graph of discontinuous functions with 5 values of x labeled as a, b, c, d, and e.
Okay, let's pause there. What is that saying?
It's talking about a function. Which is the graph. The graph, yeah. Discontinuous function.
What does it mean that it's discontinuous?
That means it's not continuous. Like the way. Which one is this? Is it sine? I think it's the sine graph that's continuous. Is that it?
It is the continuous function.
Yeah. Yeah. So that's not a continuous graph. Meaning that some parts are not continuing.
What is the simple rule for whether a graph is continuous or not? Do you remember? So the simple rule is, if you can draw the line of the graph without ever lifting your pencil from the paper, then it's continuous. If you ever have to, even for one point, if I have to go, oh, skip that point and then continue, then it's not continuous.
Okay.
At least not over that interval. What does it mean with 5 values of x labeled as a, b, c, d, e? What is...
I'm looking at the x-axis. So within the x-axis, there are values that are available. First one is a, second one is b, c, and d. Then I don't actually understand what is trying to mean.
Okay.
Yeah.
Mona, do you have an idea?
No.
Are you asleep?
No.
I can't see your face because the computer is on your chair. Can you see the screen? So, x, as you go along the x-axis, x is all these different values. Because you have x equals 0, x equals a half, x equals 1, x equals 3.467, whatever. There's all the values of x. That's what it means to be a number line. So 5 values of x, so 5 points. The value of x, therefore, if I give you a number and you say that number is where on the x-axis, you would say it's there.
Yeah.
So it's a point. So in other words, there are 5 points, 5 values of x, there are 5 points of x. And those points are labeled, we have given them the name A, B, C, D, E. So maybe A is equal to, 2.3, and B is equal to 5, C is equal to 7.1, D is equal to, it doesn't matter what the number is, the point is this is a number, and we have given it a name, like a constant. These are constants now, right? This is a particular value of x, we call it a. Does that make some sense? No, does that make sense? With us? So, now why did we draw vertical red lines, do you think, at those values? What is the value of x along those red dashed lines? Does it change?
Yeah.
No? I think down here. What is the value of x here?
That's one.
That's what?
One.
How do you know it's 1?
That is the best digit from the 0 point.
That doesn't mean it's 1. I haven't given you the scale. This could be 1,000.
Yeah.
The only thing you know is it's called A. Yeah. Whatever number it is, it's called A. So this is A. Right. Now, what is the value of x here?
I don't know.
If it's exactly above A, then it's also, where does this line up with the x-axis? Does it line up to the same point? Yeah. So anywhere you go up, this is always the same value. Vertical lines are lines of constant x. If we take the point, let me use green maybe. So if I take a point here, it will have, what will be the x and y values? So I'm taking a point, this green dot, on the vertical red line. Okay. So actually, let's start before we go there. What is this point on the x-axis? What are its coordinates?
Constant view. What's that with the x-axis, right?
On the x-axis. So
Yeah,
this
so
green
that's-
dot is on the x-axis.
0, 0, comma. A.
Plus a comma 0. Why a comma 0? Moment. Why would we say this is it's a comma 0 this point? Look, have we lost you? Is that a yes? Why do we say a comma 0? When we write coordinates, right, on a plane, any coordinate on a plane is always written as x comma y. What is the x position? What is the y position? Now, you could say, why don't we say y comma x? We could have, but in order to be able to communicate clearly, mathematics requires clarity and precision. So if you write something and you send it to someone anywhere in the world, they should be able to read it without confusion. So everywhere in the world we have agreed we always write the x first and then the y. Okay? That's the convention we have agreed on. So we always write the x value first, not the smaller number first, the x number first. So in this case it's a comma 0. So a means, right, what is a? A is the distance from 0, this is 0, 0, right? Always the origin. Right? This point here, where the two axes cross, this is the origin of our coordinate system. So this we always know, this is 0, 0. This much we know, right? Yeah. Agree with that. So then if I go, alright, move along the x-axis, a distance of a, where do I end up? Let's start with the number. If I say move along the x-axis a distance of 1 unit from the origin, where would you end up?
1 unit?
Yeah. So now if I gave you the numbers, tick marks, and I say move 1 unit, then you would go, okay, from the origin, I would move 1, where would you be? What would be the coordinates of this point?
Be 1,0.
Huh. So I'm now 1 unit on the x-axis, but I'm not above or below, I'm still at 0 on the y-axis. Right? Clear? Now if I say move over from the origin, go 3.5 units, what would be my coordinates?
From the origin, 3.5 units, then it will be going x-axis,
Mm-hmm.
and then it will be 3.5, 0.
So we go 3.5 units this way, we would be at the point 3.5, 0. If I go up, let's say 4 units, where would I be?
5.2
If I go up 4 units from the origin.
up will be 0.4.
Do you agree, Mona? So the point here, would this be 0, 4? Mona. If you start at the origin, and I say go up 4 units, you would end up at some point, right? Would the coordinates of this point be 0, 4? Yeah? Okay. Now we're going to add another piece to this. If I say from the 0, 4, move over 3.5 units to the right. So the same distance as this, but you're starting from here. So you go 3.5 to the right. What will be the coordinates of the point where you are?
3.5, 4.
Correct? Huh?
What are you saying?
What are you saying? 3.5, 4. Good. So now from that 3.5, 4, if you go down 4 units, this one's for you, Mona. If we are now, let me erase this here. If we went now to here, so we have a point that is 3.5, 4. And now I say come down 4 units. Where will you be?
3.5.
Okay, good. So this is how coordinates work. So when we label, so this line, let me now erase all these things. Maybe we'll do it like this, it'll be easier. Delete. Okay. So when I look at this line that is labeled A, right? So there's a point on the x-axis which is a, 0. What is the point here? If this is 4 units up.
Plus 8.4.
A, 4. If from the origin I go down 1 unit, let's say to here, what are my coordinates now? If I go down 1 unit, from the origin, from here down 1 unit, what will be my coordinates? A, -1. You see that, Augustus? Right. I went down 1 unit, so now I'm -1 on the y-axis. What do all of these points have in common when you look at their coordinates? The x value is always a. You're just going up or down. So we're increasing or decreasing the y coordinate, but we're not moving. We're not changing the x coordinate, isn't it? This is A. I can move up a little bit, a lot, all the way back down. I will be changing this number, the y coordinate, but I will not be changing the x coordinate. So this line is the line of constant A. Right? So if I say this point is labeled, I could give you any point on this line. So let's try another one. If I put a line here and I say this line is at, let's say this point is 10, 4. This is a line of constant what? In x. What is the x value of this line? 10. Will the 10, if I go down to here, is it still going to be 10?
Yes.
Yeah. If I go all the way up here, will it still be 10?
Yep.
Okay. So this is a line of x equals 10. This is the line x equals a. It's the same idea. Once you know the value of x anywhere on a vertical line, then you know the value of x everywhere on that vertical line. Okay. Make sense? Make sense? All right. So, I'll delete that one. Delete all these. So, let's go back to when it says 5 values of x labeled as A, B, C, D, E. Is it clear now what that means? And why there's a vertical line drawn at each of those? Okay. So read the next part here, Lana, if you will. So before we read the following two questions, what does this sentence tell us? There are? Sorry, I can't. There are questions. How many questions are there in total? How many answers will you have to give? 3 or more? So for each of the 5 values of x, answer the following 3 questions. So when it says for each of the 5 values of x, what is one of the values of x? A. So for A, what will you do? Which questions will you answer for A? When it says, for each of the 5 values of x, answer the following 3 questions. So one of the 5 values is a. So for the value a, which questions will you answer? What are we being asked to answer? The 3 questions, right? So for each of the 5 values, so I say, well, for A, answer the following 3 questions. Okay, so for A, there are 3 questions. Then, what's the next value of X? B. So for B, I also, what do? I answer the following 3 questions. So that's now 6 questions I have answered. So 6 answers I have given. Then, is there another value of X? Well, there's 5, I've only done 2. So for the third one, I also answer the 3 questions. And another 3, and another 3. So I'm going to have 5 times 3, 15 answers that I have to give. Right? So anytime we read for each of a set of things, and you can count how many there are, do the following, that means it's like a multiplication. For the 5 things here, I have to do this. And this is 3 questions that I have to answer. So 5 times 3, I should have 15 answers. Right? Okay, so now that I'm clear on that, the 3 questions are, what is the type of the discontinuity? And there are some options given. Is it a removable discontinuity, a gap, a jump, or an infinite discontinuity? Does a left limit exist? And if so, what is its value? And does a right limit exist? And if so, what is its value? Okay. Are we clear on the questions? That's a yes. Are we ready to try to answer them? Before looking at the table of answers. So, at A, there is a discontinuity at A in the function. So the function is the black lines, right? That's the graph of the function. So here, it goes up, and then from down, it comes here. There's an open circle. What does an open circle mean? What does an open circle mean again?
It means it's an open function.
It's an open interval, yeah. So the point is not included. Everything up to but not including that point. And then the closed circle means?
It means that point is included. It's
Yeah.
closed.
Okay. And we'll come up there. So this is the function. It continues through there. Does this look blue or black to you? What color is it on my screen? It's blue with black on top of it. Or black with blue on top of it. So this is part of the function. But I realize it's maybe, the blue on top makes it a bit harder. And this is also, when you looked at this, could you see that this is part of the function? Let me just bring it down so I don't have to switch that.
I think it was clear on the curve.
On the big
On the paper it was clear.
Okay, there's a part here and there's a part here.
Yeah.
Right now. Okay. So at each of A, B, C, D, and E, there is a discontinuity. The question doesn't tell you that, but it is implied by, if it asks what is the type of discontinuity, right, you can make that probably is one. So what would we say is the discontinuity at A?
Because it's 2 going up and doesn't show anything very slowly. That means it's sinking now.
Huh?
Yeah, because it's continuing.
Correct. At B, what kind of discontinuity is?
B, I think because that point is not included, then it has to be a graph. Because it's not included.
Does the function exist on either side? If the point was included, then we would just have a line continuous, right?
Yeah.
So that's actually called a removable discontinuity. If I were to give a value at that point, the discontinuity disappears.
Okay, so if that has a circle, it's a removable.
Not all circles are removable, but this circle is removable. Why? Because if I, let me see, this one. I'll use green. If I have a function like this is continuous, right? If I take out, if I say, but there's no value at this point, then you say, okay, the function is not defined only at that point. Everywhere else, the function is defined. So there's a discontinuity. I have to raise my, just for that point, I have to take it out and then I continue. But if I say, okay, now you can put the point back in, right? So you can like fill it back in. And you're like, well, if you're going to fill it in like that, then really, it's just this. Well, is it discontinuous now?
No.
It's continuous again.
Yes.
So I removed the discontinuity.
Okay.
If by adding that one point, the function now becomes continuous in that interval, then it's called a removable discontinuity.
So B is a removable. But then we're only looking at B on that side, on the B. We're not looking at the line that is coming from after the B, after the curve.
Like we're looking at this interval.
Yeah.
So there's a line here and there's a line here, and there's just the open.
Is that line, the other green line from the line, isn't it for the C?
It doesn't belong to this one or that one. The function is the function.
I mean, I was wrong on the exam. Because I wrote gap and then we might be right.
For we?
Yeah.
I made a mistake in that time.
I wrote
Mm,
gap
yeah.
and then we wrote right. Because that's a shot.
Oh, you know what happened? When I wrote the exam, I put removable gap jump for infinite. And then when I was checking, I said, okay, when I mark it, I better make sure I'm marking correctly. So what exactly, in my mind, when I wrote the exam, I thought gap and jump are the same thing. That's what I remembered. But then when I checked, I think gap is actually the same as removable. So in my mind, I had it. So yeah, removable and gap are actually. Yeah, I think that's why I'm not right. So yes, there's a gap in the function. You get here and you I have to just double this gap and then we continue. So like gap has a sense of being smaller than jump. So what is an example of a jump discontinuity here?
A jump?
Which one of these? So A is infinite, B is gap or removable, both are acceptable answers. So we have C, D, and E. Which of those would be a jump discontinuity? If any of them.
I mean, because C has one point of it is closed and the other one is open. So that means the other one is included and another one is not included. So that means the one that is included has jumped to the other one which is not even included.
So the function, right, if you follow this line, in order to continue the line of the function, you have to actually jump on it. You have to lift your pencil and go somewhere else. So the gap line, I just have to lift my pencil here and then almost at the same place I continue that. But jump, I have to, it doesn't have to be a big jump, right? It could be there's a little space. But the space is bigger than the point, right? With the distance, so I have to jump to continue. And the same with B and E. We have to jump to get from one to the other. Alright? Yeah. So C, D, and E are all jump discontinuities. By the way, you correctly noticed that at C, one of the dots is filled and one of them is open. What would happen if both were open?
Both were open.
Mm-hmm. So, right, if this one and this one, well, this one is open. If this was also open, would this still be a jump discontinuity?
I think so.
Yep. What if they were both closed?
Still be a
So, it's a jump, but also, would it still be a function?
Both were closed. Yeah.
What makes a function? So one of the things for the function to be a function, you have to pass what we call the vertical line test. Right? So one of the properties of a function is that for every input, there is a single output. So for any value of x, there is one value of y. Right? So if I go here, and I say, what is the value of y at this point? We would go here and say it's this. That's the value of y. Okay, fine. If I go here, what is the value of y right now? We would say, well, at this point, there's nothing here, so it's not like this one. Right? So the value of y is this. If they were both filled, then what is the value of y? You wouldn't be able to say, because it would have two values. So here, this would not be a well-defined function. It would not be a function. If both of these were filled, then there are two values for this x, and this is not a function, actually. So it's important that one of them is filled, the other one is not. If you fill in both of them, then what you have drawn is not a function. It's a graph of something, but it's not a function. So the vertical line test is if you take a vertical line, like one of these, and you move it along, and you say, as I move it along, I should only cross the function in one place. Right? So think about it. If my vertical line, the function crosses in two places, what does that mean? If I have this vertical line that I'm moving around, like my pen here, right? If I move it around and somewhere I go up, there are two places where the function crosses my vertical line. So there are 2 points on the vertical line that are considered part of the graph. Then that means it's not a function.
Yeah, because it's giving two answers.
Yeah. So for example, if we have a graph like this, let's start over. If we have a graph of a circle, is the circle a function? Is the circle a function? Well, maybe not.
I think it's not.
Why not?
was inside the circle where there might be a lot of outcomes.
A lot of
Yeah, and outcomes. So,
outputs. There's not the inside of the circle is not shaded. There's nothing there. It's empty. It's just the line. The graph is just these points, this set of points that make a circle. And the question is this a function? By the way, there is an expression for this, right? I can write, this is x squared plus y squared equals 1. Although, strictly speaking, I would have to center it on the origin. Yeah. This is the equation of a circle. You can do that yourself later. So you can write something that when you graph it, it gives you a circle. But this is not a function. Why is this important? Why do we care, right? You say, look, I'm good. We can draw graphs. Why do we care if it's called a function or not called a function? Why is that relevant? And it's relevant because when you want to differentiate, when you want to apply the rules of differentiation, you can only differentiate a function. You cannot differentiate this. What would happen if we tried? Let's see. So first we would write it as an expression of y. So we would say if I have x, I have to use a pen, x squared plus y squared equals 1. So first step is I have to write it as in terms of just y. So let's move x to the other side. So we subtract x squared from both sides. And then to get just y, we don't want y squared, we want y. So what do we do?
Root.
Take the square root. So y is the square root of 1 minus x squared. Is that all? Is that the correct expression for y? So you have to write plus or minus, because minus something squared gives us a positive. It's the same answer. So when you take a square root, you have to remember if you can have the positive or the negative root. Both are correct answers. So this is now 2 valued. So now if I want to take the derivative, let's do that in red maybe. So if I have y is plus or minus, I'm going to write this a different way. So we remember that a square root is like the 1/2 power, right? And if it's the 1/2 power, then what is dy by dx? Actually, this is good. We have to use the chain rule. The chain rule was which question? It was question 6, which was a similar idea. Wait a second there. Did you get the chain rule question? Question 6?
Yeah, I think so.
Did you do question 6? No? Okay, so this is a good review for question 6.
As for me, in my exam, in the exams, I let it be u. So
So you said that u equal what?
u is equal to 1 minus x squared.
Okay. Then what?
Then I
Let u equals what?
differentiated each using u. So that means it will be u to the power 1 over 2, whereby when I differentiate it, it will be u to the
So,
power
hold on. So you say now du. No. So now y is d by dx of plus minus u to the 1/2.
So you want to differentiate. You want to differentiate with respect to x, but the variable is u. So how do you go from d by dx to d by du?
How will
Right now, the way it's, what we want is dy by dx. We want the derivative of y with respect to x.
yes.
So you're making a substitution. Let u equal 1 minus x squared, which is fine. So then y can be written plus minus u to the power 1/2. Yeah, just correct. But I still have d by dx. You can't differentiate. What you want to do is say it's 1/2 u to the minus 1/2. That's the rule. But to do that, what you are doing then
Is d by du of this. And then that is equal to plus u to the minus 1/2. But there's something else that has to go here. How do you go from d by dx to d by du?
When I multiply by the value that I have, which has to be differentiated in the same way it is.
So you need the du by dx. So in other words, what we're doing is that dy by dx is dy by du times du by dx.
that's the chain rule. And it's easy to remember. These are not quotients, remember?
Yeah.
Yes, Mona? These are not quotients. This is not dy divided by du. It's actually an operator. Right? It's d by du of something. D by dx of y. But we write it that way. But writing it this way, helps us remember the du. It's almost like you could cancel these two, and you would have dy over dx. So that's the way I remember it, but it's not because we're doing algebra. Okay. Actually. So what we did here, so then the dy by du, then we wrote y instead of writing y as a function of x. So actually, it's this.
So we're writing d by du of y as a function of u. I don't know why my pen is messing up like this. Times d by dx of u as a function of x.
That's the full expression of what we're doing.
And maybe just to be clear, it's this times this.
Hmm?
When you come again, when you relate it like that, it's confusing. Because-
It's more precise. Which, this part is confusing or this part is confusing?
That part.
The second one.
Yeah.
Uh-huh. What part is confusing? So I have d by d, dy by du, which is this. That makes sense, right?
Yes.
And I have du by dx, which is this.
Ah.
Right?
Yeah.
I'm just writing here, it's a shorthand, right? We're saying the function y, but you remember a function, really when you write a function, you say it's the function of this variable, f of x, g of x, y of x. But in this case, you are writing, right? This is not y as a function of x, there is no x here,
Yeah.
there's only u. So now it's y as a function of u, where u is a function of x. Right? So when we said let u equal this,
What we were actually saying is let u as a function of x equal this. Sorry, this is messy. Let's clean it up. So let u of x equal this.